Good night, or sorry, good evening, everybody. Few people here in person enjoying some tea and treats. We've got a few people online as well. My name is Matthew Watkins, and I am the chair of the Rotten Sustainability Commission and part of the Energy Task Force here in town. And we're putting on a series of home energy retrofit talks this winter, looking at the different ways in which we can reduce our energy costs, increase the comfort of our home, as well as take steps towards reducing our greenhouse gas emissions. I just wanted to start off, sorry, multitasking here, running the Zoom. Start off by acknowledging that we're hosting this talk tonight from the traditional territories of Synax peoples. I came across this interesting map. When we're talking about energy in this part of the world, it really brings the experience of the Synax peoples into context. So there's a couple interesting dates here. 1956, the Arrowlake Indian band was declared extinct, and that's conveniently 5 years before we flooded the Columbia for a nice clean power. Yeah. And then it took about 60 years. So just going to start off with a bit of a pitch for the Sustainability Commission. The Sustainability Commission is a group of volunteers here in town focused on making the community a better place. And so we've got 4 task forces that are currently operating. Volunteers sort of associated with each, working on projects under each. If you have any interest in these topics or interest in getting involved in something in the community, please get in touch with us. You can reach out on email, follow us on Facebook, or check out our website. We're currently working on this Earth Day event that a lot of people are doing. So if you're keen, please do not hesitate. So tonight's the second talk in the series of talks we're doing this winter. Our next talk, February 22nd, we're going to be doing a deep dive into a home energy retrofit here in town that's been going on for the last couple of years. So the homeowner is going to be here for that. I'm hoping also to get homeowners here to talk about their projects. March 8th, we have Better Homes BC lined up to come in and to us with heat pumps. And then I'll talk, the assistance program is going to come back. Jeff is going to come back. So just want to review the energy efficiency pyramid. We went over this last week. And talked about the importance of this pyramid in guiding you through the most effective energy. And so basically with this pyramid, you want to start at the bottom and work your way to the top. The bottom tax, the bottom hurdles are the least complex and the cheapest, and also can have the biggest impact. Furthermore, they also have an option to the efficiency of the education. So last week we talked about home energy audits with the EA. And the pyramid, and see. Also want to promo, we have infrared cameras for loan at the library right now. We have one for iPhone, the Androids. The iPhone ones are in pocket. So one can the Android ones seem to be available. But these are a cool tool that help you get a visual of where you're losing your heat in your home, and really brings some of the theories that we're talking about. Just help you. So We're fortunate to be joined tonight by Jeff Kirkpatrick, who is an air sealing specialist in the region, and he is going to talk to us about things air sealing.
Good evening, all.
Going to change the show.
No, I can do it. Yeah, just answer with good. Okay, technical difficulties overcome. Good evening, everybody. I'm here tonight on behalf of the Community Energy Association. We're going to run through some slides just to give us context on some of the elements that we can discuss in a little more detail. Because you've probably seen a lot of these slides, we're all sort of working from the same basis points of the BC housing guides, and so you may see some additional components. This slide deck was put together by RDH Building Science out of the Lower Mainland, the authors of the BC Housing Building Guides. And so you're going to see in that text some of the same slides. What we'd like to do is sort of breeze through two components. So I've got one slide deck on improving building envelope air tightness, as well as Retrofit House 101 and House as a System. So if we can get through both slide decks and open up the floors for questions and input from individuals. So moving on. Session overview, we want to discuss measuring and improving air tightness, insulation and R values, windows and doors, prioritizing improvements and risks, and common errors. So first element is measuring and improving air tightness. So as Matt was saying, you guys have got a brief on the red door assembly and what the metrics that can be derived from that. So measuring air tightness with the blower door is a quantitative air tightness measurement is useful starting point to get a number in air changes per hour, your ACH rating on your home. So that's how many times per hour is the conditioned air within your space having to be reconditioned to maintain good indoor air comfort. A calibrated blower door fan is used to pressurize or depressurize, which is either adding air into the space or pulling air out of the space. In order to measure the air tightness level of the building. The number indicates the volume of air that can be blown through the envelope under standard test conditions. So a number of 10 ACH is 10 air changes per hour. So that means I'm conditioning that interior air 10 times per hour to maintain that comfort value. And at 10, you're probably living in a 1901 house with wood chip insulation, because that's a fairly high value. Getting down to 4 ACH would be a much more consistent with current, 1990s newer builds, done consistently well. We can get down to 4. Just for context, if we're familiar with passive house, that's at 0.5. That's a half an air change per hour. And then our current standards, we can get down to around 1 ACH. Is a very good metric. We've built numerous homes over the last number of years at 1 ACH, and they perform very well, respond well to good mechanicals. Related to, we have two major metrics within buildings. One is your TEDI, your thermal energy density, and your MUI, your mechanical energy. So if I turn up my TEDI, I can reduce my MUI, my mechanicals. So if I can increase the building air tightness and insulation values, I can turn down my mechanical needs. Measuring air tightness of the blower door test at standard tests, the EASTM E779, even used in modern homes, it's pretty much a standard metric. So we're zero energy house at 0.6 air ACH. Energy efficient house is 0.6 to 4. Typical new houses prior to the current standards are 4 to 6. And then we can see as we go back in time, we just get steadily higher ACH. I was out with an EA just last week, and we had a house at 17 ACH, which is just unbelievable. The door, that door was that's 1901, and yeah, everything in the place leaks. So most older homes, and we've got quite a varied housing stock in the region in the Kootenays, and so we're getting some fairly high numbers still. The goal would be to make the home as airtight as possible. But like I said, if we can get it down to 1 ACH, it's a really comfortable value, and you can reap the rewards of reduced energy loads at that value. Measuring your tightness with a smoke tracer. So once you have a number, you can qualitatively test air tightness using theatrical fog, tracer smoke. We've got small one here. I've got visual aid. Small one here. Sorry, I don't have it with me. I've got a small one that if people want to see it in action, they can contact me and I can come out and we can use the smoke and infrared in order to identify air leaks, whether it's pressurized or not. It works quite well. So you can get small handheld units. You can get the same effect with just simply a feather or a candle or any smoke generation. Very handy visual aid in order to increase the visual impact of where those leaks are and the intensity of those leaks. With an infrared camera, very telltale, you get instant results, very visible. On the left of this photo, we can see that is under a pressurized environment on the outside. So I'm pulling warm air from inside the house out, and I'm seeing leakage at the top plates. At the walls, that leakage can transmit it down into stacked corners. We don't get a lot of insulation. Depending on the framing style of the corner, you usually have a void in there, and it's usually missed with being able to pack with insulation. On the right side, we see a depressurized home. So we're on the inside, and we're drawing cold air in. We can see air coming in through vent locations, pot lights in the ceiling, generally around the top plates of the wall, as well as interior corners. So improving building air tightness by air sealing is usually one of the most effective ways to improve the energy efficiency of the home. So an existing home at 8 to 10 ACH is a high energy usage. We're drawing a lot of our mechanicals to try and condition that air. Improving air tightness, all air in the house can be air sealed using appropriate tools and procedures. The goal is to reduce unwanted and uncontrolled airflow through the building envelope. The three strategies are targeted draft airproofing and air sealing, which is your windows, doors, and penetrations. Indirect improvements from retrofitted windows and doors. The majority of windows are incredibly leaky. We say there's two types of windows, ones that leak and ones that will leak. And then a full air barrier retrofit, whether that be an interior or an exterior air barrier retrofit. And we'll touch on thermal insulation and R value. So a reminder, thermal insulation is a material that resists heat flow and therefore insulates the building. The higher the R value, the more the insulation. And R value is either an imperial unit or RSI is a metric unit. And simple conversion is either multiply or divide by 5.678 in order to flip those numbers around. The insulation material is used to insulate the building and provide R value. Note other layers in the assembly, your cladding, interior finishes, framing, also affect the assembly R value. This is referred to as your effective R value. So when we look at a bag of insulation, we see it's an R20 bag. That's a nominal R value rating. But when we calculate the wall from a building science point of view, we calculate the wall with the studs, framing, sheathing, all of the elements of that make up that wall. Either reduce the R value or improve the R value. And by calculating all of those components together, we derive the effective R value of the wall. So we can see that it makes it's quite a smaller number than. So targets for improved R value vary based on assembly and climate zone. But as a rough guide, and we've got Castlegar out there, but I think that we're near the same climate zone here. And that's based on our wood frame building enclosure assembly at the just shy of 4,000 heating degree days per seasonal. Your attic spaces at R40, your cathedral and flat roofs at R30, above grade walls at R20, floors at R20, suspended floors at R25, and slab on grade floors at R10. So thermal insulation, other insulation components are your opaque. The opaque assemblies are not the only thing resisting heat flow in a home. Windows, doors, and skylights should all be considered as thermal insulation as well as part of your air barrier. Critical thought to keep in mind is that windows, doors, and penetrations in the envelope are part of the air barrier assembly. whether that's an interior or an exterior barrier, they still qualify as part of the air barrier assembly. If window and door replacement is being considered in retrofit work, the energy improvements can be significant. And the overall thermal performance of home is dramatically improved by focusing on the weakened slate, which generally is poor windows and doors. Improving insulation and average R values, all assemblies and components can be used to calculate the average R value or a weighted average and can show where improvements are most beneficial. So during your energy advisor application, we calculate all of the components of that assembly and get a weighted average to give you a value to the wall. So just because I have R20 insulation in the wall doesn't mean I have an R20 wall. And multiple walls within the home can all be different values. And then we calculate in your windows. You might have very poor windows in an R1, or you might have good quality windows in an R5. So we take that weighted average in order to determine the existing conditions. So an example of an average R value improvements, say the existing 1970s rancher, typical walls at R12, and I've got 1,000 square feet of wall space in this home. My attic insulation at R20, and I have a 1,200 square foot footprint, and an R20 floor assembly at another 1,200 square feet. But my windows at R1 have a combined 125 square feet of wall window surface. So my average weighted R value is R10. So I may have R12 walls, but I really have an R10 assembly. When we look at the windows being the weakest link in that assembly at R1, 3% of the envelope area, it's also 38% of the heat flow loss. So if I was to just do an attic top up and add another R30 to the attic space, another that would qualify as 9 inches of new attic insulation, my average weighted R value improvement, 12% up to R12. So it has some value to it. It's a fairly inexpensive application to get in and insulate an attic, and it does have benefits. If I was to upgrade windows, new standard Energy Star windows at R4, I would have a 39% improvement up to R15. So quite an impact. So yes, a more costly application.
Is that accumulated? So the combination of both the attic improvement and the window?
No, well, yeah, that's just if I was to address the windows.
Just when you start.
Yeah. So if I was to add 6 inches of new attic insulation and get myself up to R60, or sorry, R40, with my R4 windows, I would have 58% improvement up to R17 as a weighted average for the building, which is quite considerable. So an example of improvement summary, adding insulation to an opaque assembly, even R30 of new insulation had a relatively small impact of 12%. Improving the windows from R1 to standard modern R4 had a significant impact, average R value at 30% or 38% better. And then combining upgrades, even with less attic insulation, had the biggest impact at 58%. This concept applies to all assemblies and combinations of envelope improvements. Windows and doors are always a good starting point, if possible, and upgrading them provides other value like comfort and airtightness. And your EA would be able to do that evaluation and give you more insight. So let's touch a little bit on the weakest link, which is windows and doors. Windows have a large impact on energy efficiency for a number of ways, and we've come a long way within our window fenestration improvements in product and durability. It's helpful to understand some basic characteristics of windows, even if you aren't directly involved in the place of work. An energy advisor can provide more detailed information, and knowledge is both helpful for clients and members of the team. I think that this was actually directed more towards contractors than this slide deck. So while still a measure of thermal insulation, window products use U value or U factor as a standardized rating, which is the inverse of R value. U value is the measure of heat flow, lower is better, instead of thermal resistance. U value depends on frame and glass and also applies to doors and skylights. Does it tell us here? Before we go through further, I'll just mention that when we're shopping for new windows, in any kind of energy upgrade, ensure, and I think we have a deck here, but ensure that they meet Energy Star requirements. There's a lot of window manufacturers out there touting a good quality window, but they may not be registered with as an Energy Star product. And if you're going for rebate programs, it's incredibly important. Our windows are also a marketing game. So we have to, when we measure U value, it's important to read the literature for the window, or at least acknowledge them to be knowledgeable, because a lot of window manufacturers, the metric is the center of glass U value. But window manufacturers will try and slip in the fact that they've quantified the frame and glass, which gives a non-true representative of the true U value of that window assembly. So you'll get a deflated U value because they're quantifying the frame as well. If you're looking for a consistent metric, then you're taking center of glass U value. So what makes the difference in a standard double glaze, standard frame, whether it's aluminum or vinyl, one coating or one plane of that double glaze has a low E coating on it. That's your minimum standard. We can see there that's a flanged window. And even you'll notice here on the diagrams, this flange represents a flange window that's face mounted to your framing system. These are what we call rebate windows, and they're held into place with clips, so you don't have that consistent contact with the framing, which is a conductive element, which reduces your thermal resistance on that window. A rebate window, which all, as we move forward here, flange window is sort of a thing of the past. A rebate window is going to give us much more thermal resistance, as the fact that it has less fastening to the framing elements, so we don't have that conductive loss through the framing, which we measure in a chi value. So as we move forward and move across, we have a triple glaze chambered frame, so that's a hollow frame, and one or more of those planes of glass carry a low E coating, or are argon or krypton fill. Krypton would be the more expensive and the less thermal conductive. And then the top of the line would be the insulated frame, because now that insulation layer is in contact with my framing element, my rough opening, which is in contact with my insulation layers within the wall assembly. So if I can maintain a plane of continuous insulation right to the glass, then I've increased the thermal performance of that wall assembly dramatically. We'll just touch, yeah.
I'm considering replacing windows, so I'm just curious, like, say a window manufacturer says, oh, you buy this. What sort of like keywords do I need to be looking at specification?
First question is that taken from center of glass, or is that including the frame?
Okay.
Right. And most manufacturers are now realizing that we have to have that consistency. So when we go to high performance windows, especially Energy Star rated windows, they have performance metrics that they have to maintain. And so that dialogue is now becoming more universal. Yeah.
Generally, if it has that start, okay.
You're on the right track. Yeah. And then you can break down. Sorry?
So say it doesn't have an energy source, so it could be okay.
It could be, but there's not too many manufacturers that are producing a high performance window these days that aren't part of the Energy Star rating, just because of the necessity for sales and compatibilities. Right? And I would always press towards an insulated frame for your best value. A hollow frame is a big improvement from yesterday's standard vinyl window, but an insulated frame has that much more performance value to it. So we'll touch on window solar heat gain. Solar heat gain coefficient is a measure of heat gain from solar radiation. It's tricky, the higher number, the room gets hotter from the sun, more heat gain during winter can mean less mechanical heating, but too much heat gain during summer can mean poor thermal comfort or extra cooling needed. So your site location plays a really big part in this. So if you're within a city or an urban environment, you're maybe not so susceptible to that drastic coefficient between winter and summer. I'm in a rural environment and I've got 10 big windows on the front of the house. So today, with no heat source whatsoever in the house, I got over 24 degrees. But as soon as that sun went down at the end of the day, it dropped right down to 18 degrees within a matter of 45 minutes. So it's a dramatic impact. But then, and that's a benefit to me in the wintertime here. In the summertime, it completely kills you. So you get the long wave radiation coming in and the short wave radiation not being able to get back out. And it's heating up the space considerably during the summertime, which increases our cooling loads, which has a massive impact. So window low emissivity coatings impact the solar heat gain and U value. So homes can use different solar heat gain for different walls. So I would, if it was my choice at the time, I would have put a different rating window on the front of the house. Your energy budget should advise on this, as well as there's a lot of great information through some of the builder guides and the CMHC and BC Housing. Low emissivity coatings are not the hopes of the strand, but commonly glass products offer various options. And I know that there's quite a bit of new stuff coming out. 3M is providing new coatings to improve the solar heat gain value, so that we can still maintain some balance between the winter and summer heating and cooling. Reduce need for low solar heat codes. So good R values, windows and air tightness, reduces the need for solar heat gain as an energy savings measure. So use lower solar heat gain where possible as the basis for this design. And coming into play, like I say, with orientation to site, we have high sun in the summer, and we have low sun in the winter time. So solar, you can have shading on the outside of the house in order to compensate for the summer solar drive. But in the wintertime, that shading that falls below that plane is Memphis, and we can pick up that solar heat gain in the wintertime. So in my case, I'm going to be applying shading to it so I can block out some of the winter impact or summer impact, but still realize the benefits of the winter impact. So with the coatings, we can limit some of that. So energy efficient window product selection, U values don't mix up imperial and metric, which will give you in odd numbers. Window size impacts U value, compare apples to apples, and keep an eye on glazing, check double or triple. So we have an example of a energy label for a typical window. It gives us our zone, it gives us our U value, our solar heat gain coefficient, and all of these can be actually checked through the Enercan website as to whether or not they meet the requirements. Their U value, solar heat gain. Repeat. Right, so just to give them a value of our imperial and metric, where we're watts per meter square at Kelvin, or either BTU per hour, Fahrenheit. So an R3.8, which is a typical flange window, and that's even high for a lot of flange windows out there these days. But some of the high performance assemblies that window manufacturers out there right now are making R8, R9 windows. And there's some really cool technology coming around with aerogels to even increase that further in the next number of years. So U value, often hard to find on manufactured websites. They're usually made for consumers. So that, as I say, finding that center window U value opposed to a whole window assembly U value. There's some great information on the web. I just came across some good YouTube videos on this from some local manufacturers. So check out the Enercan Energy Efficient Rating website for Energy Star windows. You can select your product and determine whether it meets the requirements. There you can simply click on your windows, find a manufacturer, and check out the data on those windows themselves. Reminder: air, water, and structure through NAFS and the North American demonstrations. Window products must have a NAFS rating unless they are specifically designed and sealed, stamped by an engineer for the project. NAFS also air tightness plays a role in overall air tightness, and manufacturers provide the test data certification for NAFS sticker. So I've tested a lot of windows for Cascadia Windows, Innotech, some of the higher performing window manufacturers out there. And so we have to evaluate not only their water penetration, but also air tightness. Basics for choosing windows: first-hand experience or other market forces are good guides. Compare apples to apples. You guys with solar heat gain, not just marketing. Use Enercan and product references. Start with numbers. Assess the thermal and air tightness characteristics. Are they double or triple glazed? Frame material. Typically, at this point now, we're going to be either fiberglass or PVC. Are they argon filled or in some cases krypton filled? The operability and gasket type of number. So there is a number of gasket placements. I'll just go back here quickly. We benefit here. So you can see in these high performance assemblies, there's more than one gasket, not just a gasket at the primary seal. There's more than one gasket to maintain that air tightness element. And windows take quite a bit of abuse. We see a window in an opening and it's a static thing, but we have seismic movement, we have thermodynamic movement throughout the building, throughout the temporal seasons, and that window's taking quite a beating in that opening with the wood frame building moving around all the time. So window door review. Windows have a large impact on energy efficiency. The thermal performance are rated with U value, and in general use low solar heating windows. So an energy advisor can provide more detailed information as well as Enercan. So prioritizing improvements. So not every house can get a full report or retrofit. All improvements are beneficial, but there is always a trade-off between cost, time, and energy efficiency gain. It's better to address the low-hanging fruit than to do no retrofit work at all. There are three basic categories of energy retrofit work. A, being simple insulation top-up for smaller budgets and where interior or exterior retrofits are not possible. B, an exterior retrofit where significant energy improvement is desired and interior retrofit work is not feasible. And C, interior retrofit when significant energy improvement is desired and exterior retrofit is not feasible. And that would be, in the case of maybe a heritage house where we can't address the exterior or heritage values, so we may have to concentrate on an interior retrofit. So under priorities, the insulation top-up for smaller budgets is going to entail air sealing. And because, obviously heat rises. So that's where we're getting a majority of our heat loss without any pressurization on the building. So I don't have wet wind pressure on the building, or I don't have stack effect where I'm drawing air in through a leaky basement and pushing that warm air up through the attic. Either way, attic air sealing is always a great first step. It's where we're getting a majority of the loss. So attic air sealing and then attic insulation. Crawl space air sealing, because that's where we'll get a lot of infiltration as a result of pressurizing in the home. Crawl space air sealing and crawl space insulation. I want to move to exterior retrofit when significant energy improvement is desired and interior retrofit work is not feasible. It's going to be crawl space. It's going to be all of the first elements plus crawl space conversion and insulation retrofits and window and play replacement. So generally a deep energy retrofit where we take the exterior off, put an exterior area on, add exterior insulation, and replace all of the windows to match.
What is a conversion when you convert a crawl space conversion?
Generally, you may have a projected space or over a garage or anywhere we have an uninsulated conditioned space underneath the floor space. So I've got conditioned space above and an unconditioned space, and I want to convert that so that I now take my full envelope footprint as part of my conditioned space. So I'm converting that unconditioned spaces into a conditioned space. This is probably difficult to read online. The envelope improvement options, insulation top-up within an accessible attic. Simple, easy area to address. I can get up there and do simple air sealing around hot lights and penetrations, and then add additional insulation. Vaulted flat ceilings, I'm going to have to address from the inside, which means putting, gasketing hot lights and dealing with any cracks, top seal, above grade walls. Not much I can do there, whether I'm either doing exterior or in this case an interior. So all I can really do is top seal maybe my as an interior airtight drywall approach, where I'll seal my drywall to the floor and windows and penetrations. Below grade walls, I'm going to seal up any air leakage, cracks in the foundation, and primarily at the headers at the base of the foot of the wall. Plenty of leakage at the bottom plates to the concrete connection. Crawl space ceilings. I'm going to air seal from below during insulation work, and windows and doors means generally caulk sealing. We don't promote doing spray foam to air seal your window. Spray foam is a degrading product. It doesn't have the long-term value. So we'll use a sealant to create an airtight seal around the window penetration. An exterior retrofit, I can do interior insulation within the space itself. With a vaulted cathedral ceiling, I can put insulation on the outside of the roof assembly, and now it becomes part of the conditioned space. I can add insulation to the exterior of the walls, as my wall is set by upgrade walls. My exposed floors, same format, I would insulate and air seal. Below grade walls, adding insulation to the exterior of the wall as a primary benefit opposed to the interior, but can also be addressed from the interior. And my crawl space ceilings, same, I'm going to add insulation and air seal to those elements and replace the windows with high thermal performance windows and doors. And then interior retrofit, where budgets and time and convenience will allow. Same addressing the added insulation, my flash and fill for my attic areas, vaulted ceilings. I can add insulation to the inside of the structure. I can add insulation to my interior walls and reclad them. Same format for my exposed floors, below grade walls, adding insulation and airspace to the interior of those below grade walls. Crawl space ceilings, adding insulation, and windows and doors again replaced with high performance thermal windows. Pop-up priorities, always prioritize air sealing. So adding insulation is a nominal value if I haven't addressed the air sealing. So insulate where possible without removing finishes and exterior components, and more to come. Interior and exterior retrofit priorities. Windows are usually the weakest link. Exterior retrofit work is usually lower risk and can be done during other renewal work. Prioritize air sealing, adding new air barrier, and exterior insulate where possible. So the exterior retrofit, adding when we refer to low risk is because it's the purest plane. When we go inside, we've got twice as many interior corners and partition walls and all kinds of elements on the interior that make it quite difficult. Generally on the outside, we've got a straight flat wall. We can strip it down. We can use conventional materials, tie-back and high-performance tapes to create an exterior air barrier. Very effective. Replacing the windows at that same time, upgrading, adding insulation to that exterior, and then recladding the building in cost-effective formats is going to give us a best bang for the buck. That's the most return you're going to realize as far as any type of retrofit work, addressing it from the outside. Not to say that we can't do it from the inside, but it does make it a lot easier. So we go back to our rancher example, interior and exterior retrofit priorities. Remember, average R value. So all improvements are beneficial. It's better to address the low-hanging fruit than to do no retrofit work. And there are three basic categories. We'll touch on the risks and common errors in any retrofit work. Overall risk from improving the envelope, remember the system. Air sealing can lead to combustion spillage. Air sealing can lead to poor indoor air quality, and improper retrofit work can trap moisture within the wall assembly. If improvements are not properly prioritized, effort and cost may not be well spent. And if air tightness is not tested, air sealing efforts could be wasted. So mitigate risk by consulting with an energy advisor, which is doing a whole building assessment, assessing air tightness with the correct tools, smoke pens, and thermal cameras, and take appropriate certification training. This is the reply to ensure that you hire certified contractors to perform the work, especially if you're going for rebate programs.
It's a challenge around here.
Certainly, yeah.
That's one of the things that people you're in a position to support.
I think it's going to improve. The education is out there for contractors, and things are definitely, we have improved metrics already, and I think that it's going to become more prominent as we broaden into the rest of BC. Mechanical risk systems. If mechanical heating cooling systems replacement is planned, retrofit work must be carefully coordinated to avoid missizing the replacement equipment. An improved envelope can allow a smaller mechanical system, but it should be confirmed by the energy advisor, which is doing an assessment. So you would do any air sealing and insulation work before planning what size units you're going to put in there afterward. So you do that air sealing and insulation work, have a reassessment done, know the metric for the building, and then size the equipment to the building. An improved envelope can allow a smaller mechanical system, but should be confirmed by an energy advisor. If envelope improvements are not as significant as intended, the new system may be undersized, or if the envelope improvements are significant, the mechanical system may be oversized and lead to short cycling. Common envelope improvement errors using snake oil products that claim extremely high R values. We have lots of data and lots of guides to refer to, so ensure that whatever options you're looking at are vetted. Relying solely on marketing for window and door products, as mentioned earlier, we have to ensure that we're getting the right metrics. Topping up insulation with air sealing is going to limit the amount of effect that you're going to get from that top up. And using low-grade products and approaches to envelope work doesn't ensure that we have the durability in order to realize the value. And not using an energy advisor or an airtight measurement or assessment will not give you the value, the metrics you need in order to make good decisions. Session review, measuring improving air tightness, use of lower door fan and visual indicator, insulation and R value, insulation improves windows doors, use average R value concept for weak links. Windows and doors, compare with product U values, lower is better, and avoid high solar heat gain. Prioritize improvements, top ups to exterior retrofit, to interior retrofits, and risk and common errors. And that's it for that.
I don't actually other one loaded, but I can switch over to.
Yeah, we're at 746.
I had a question about the air quality events, air exchange rates. Like say, we look at these retrofits on the home. Yes, it's pretty drafty. We do all air sealing. There's not a lot of like a bathroom fan. They don't have a kitchen.
Yeah.
Like what sort of system beyond the heat pump, super expensive system?
The impacts are the primary impacts. So if I increase my air tightness and I increase my air tightness metric alone. So if I increase my air tightness, the building's not performing the same way that it had been prior, historically. So primarily, actually, I think it's touch on it in here. But primarily, what's happening is we got big, leaky houses at 10 ACH, and our houses sort of exist on a fine balance between wetting and drying. So you may be in the wintertime increasing humidity levels within the home, which is condensing in the wall assemblies because we don't have a large enough thermal gradient to the wall itself. So that cold, dry air on the outside, my warm, humid air is moving through the air leakage within the wall assembly. And as it moves towards the cold, it condenses within the wall assembly, usually within our sheathing plane. So our buildings, typical homes, like we looked at that 1980s rancher. So that building during the wintertime is probably condensing on its plywood. It's definitely condensing in its attic space. But there's so much air leakage that throughout the season, as we move into the warmer months, that is being flushed out of the building, and we don't necessarily see mold show up. It doesn't mean that that building is not producing conditions that would produce mold. It's that we have so much drying potential in our leaky building that it's being recycled every year. So it goes through a wetting drying process every year. So if we go and increase that air tightness, we have that humidity now stored. It's condensing with the wall assembly and potentially causes mold. Right. So part 9 says that at our current code standards says that we need to have one ventilation unit running all the time. but it doesn't work for prevailing science because when we're exhausting all that conditioned air, we've just managed. So if I'm going to improve air tightness, as my own personal, I would improve air tightness, improve thermal, and then I would move towards a heat pump or an HRV in order to realize that air. We're in an environment now where we have, forest fires and smoke. I'm not trying to push HRVs, but they do have their benefit because I can have a MERV for the 13 filter in there. I can have fresh conditioned air and guarantee that I'm not going to have allergies or mold buildup or condensation elements. So that, it does work. But if I improve the physical elements of the building, which is the 5 critical barriers. So I need a water shedding surface on the outside, my cladding assembly to shed 90% of the water out. I need a water resistant barrier as my final pane of protection. That would be your tieback or your sheeting paper on the wall assembly to keep that last 10% of moisture out of the wall assembly. I need my thermal barrier to increase the conditioning of the space within the home. And I need my air barrier and my vapor diffusion layer. Those are your 5 critical barriers of any wall assembly. If all 5 critical barriers are dealt with appropriately, we have a very durable building. Now,
still the need for an HRV or
you still need conditioned air managed inside.
So if you're undertaking an air sealing exercise protocol, like you're HRV, like where would you do the air sealing and then seal?
It depends on how far you've gone. So if you've gone, you've done that, the basics as a homeowner application in regards to air sealing and adding insulation, and you really haven't changed those metrics, you can put on sensitive fans that are register humidity levels, will flush the air. There's quite a few units out there. There's smaller versions of an HRV. They can be zone specific, so you can get small units that can ensure that a concentrated area like a bedroom can realize that there's fresh air there. But that's where it's important to have the assessment done prior to, and then through that metric be able to evaluate because there's also the long term. I mean, when we purchase a house, I plan to stay there quite a long time. So it's a big investment for myself. So I want to see, where am I going to see my long term return on that value?
So somewhere on this
there'll be recommendations within an assessment, but you'll also know, you'll have the data to make an informed decision on how far you want to go. Do I want to go to an HRV? Do I want to manage it with just a heat pump? Do I want to look at the mini splits or zone specific smaller elements? Quite a few metrics there that play with you. There is no one right answer.
Yeah.
Right. I mean, just your wind exposure can play a big part of that, right?
Yeah. We did a talk last winter as part of the series looking specifically at ventilation. So we spent a good half an hour looking at the different ventilation options that makes everyone check out.
Yeah, it's available.
Quite a number of products out there to meet your needs now, and even more.
In the investigative work we've done thus far, which is fairly basic, but also they go in square footage and depending on who the installer is, the person you're recommending, in this case, plumbing and heating, they're still, they don't really take all the factors into consideration. So they look at the square footage, they recommend not taking into the fact that, I'm doing a complete exterior retrofit. And until I've made the decision now, I'm going to hold off until I've gone through the project and then final assessment on the energy advisor tasks. Then I'll decide what's appropriate.
And that really is critical because once you've done your basic improvement upgrades, you have a whole new metric to the structure to evaluate, and that's going to give you a quite detailed, number to work with as far as what your requirements are, and that's that oversizing or undersizing piece of equipment to meet your needs.
This may be a little bit off the topic, but I'm just curious how they might think this rebate program timeline, like it just saves your post assessment. Still be a bit of
Yes, I understand. I understand the critical part is getting an assessment.
Yeah.
And that you're still eligible like they recognized that it was a process. Really, the advisor was really good at knowing how these programs work. And from what I understand, I can pull off and make that decision right now. And down the road.
Yeah.
I don't know how much money I've got, right? But it'll depend on finance too, right? So, although it also depends on how big the home. That's, so, and like you're going to tighten the home. I'm concerned about interior air quality. So, is it something I can put off? Or is it something that really should be dealt with?
And like I said, the two critical metrics that you're worried about today, as far as indoor air quality, is one, combustion spillage, if you have any, fuel burning appliances within the home. If you don't, then you can kind of rule that out. And now you're only worried about those seasonal changes and whether or not I'm building up too much humidity within the house. Am I depositing, the condensive plane within that assembly and potentially causing mold, which would be sigmite and, eventually cause respiratory issues. So, and those things sort of take time as well. So you're not going to have major reactions within the first month of doing some air sealing. So that, it is some resilience value there.
And you'll know pretty quick. Like,
Yeah.
I got a 59 bill and I pulled the drywall, replaced the insulation, and they had paper back insulation before. I put in a vapor barrier. That winter, my windows froze. Like, I got sheets of ice on the glass. And the humidity was like an obvious issue right away.
So that humidity,
Then we had to install.
yeah. So prior to that, humidity was moving through the envelope.
The paper,
Now you trapped it inside. The first condensing plane, the coldest condensing plane in that wall assembly is the window. And you see it right away.
And it's yeah.
Oh yeah.
And then of course the other risk is what is actually happening on the other side of that ground.
Oh yeah.
Yeah. So
water damage.
so recognizing there's a greater risk as well as far as a long-term property building.
Yeah. So we want to run through air sealing. I think this is fairly quick. We're getting close on time.
Yeah.
Let's run through this one quickly. So session overview. Benefits of air sealing, non-invasive air sealing procedures, windows and doors, and alternative air sealing approaches. So the benefits of air sealing, obviously, are a conditioned space where I can enjoy good air quality and thermal comfort. So improving building air tightness by air sealing is usually one of the most effective ways to improve the energy efficiency of a home. You can see there our existing home at 8 to 10 ACH, air changes per hour, slightly improved envelope where I've done some basic air sealing. I can get it down to 4 to 7, and we're still representing 4 as an excellent value. I'd like to see something around 1 personally, but air sealing means better comfort and air quality. Airflow leads to discomfort in cold spots, and less air leakage means it's easier to heat and cool and keep stable and comfortable temperature. Less air leakage means better comfort and air quality. Uncontrolled air infiltration can also lead to outdoor contaminants getting inside, and a good air barrier allows better controlled filtered ventilation. Remember, houses and system, ventilation is important with air sealing. So an exhaust fan and fresh air intake, or an HRV or ERV system can manage those metrics. So basic air sealing procedures. The air barrier is not the vapor barrier. Vapor barrier is vapor diffusion. It does not need to be sealed. So we don't need to tape and seal a vapor diffusion layer, only the air barrier. It's only when we have the poly working as dual purpose as air and vapor barrier that we want to tape and seal the poly. Air is the carrier of vapor. Vapor by nature is done. It'll just go to the same location. Air is smart and can go and find its escape plan. So in this case, vapor barrier only needs coverage, whereas an air barrier needs continuity. Appropriate tools and membranes or materials. So you can see here, we've got, these are what we call bolt guns, and we get sealants in the performance sealants, ones that exceed our 50-year lifespan. Close to 25 here. You can purchase in bulk the cartridges, or opposed to smaller cartridges. There are large applications of air sealing. We have performance safes, and there's other products that we just see about. We have prop packs for the homeowner for there's a two-part closed cell straight home application for hard to reach locations, headers, rim joisting, boxing under floors. Box like this. We have smaller increments as well as smaller increments of insulation. Good.
Yeah.
And less than ideals, ideal tools and materials. Alex Plus is not a sealant as far as tape is a linear product. It doesn't make annular penetrations. Great stuff type products from Home Desperate and Rona are not. They're open cell products and they degrade quite quickly over time. Non-continuous insulations without an additive to it is not an effective. It doesn't have effective R value, and a lot of the foam gasket tapes do not maintain their fluffy coefficient.
Like sitting buses and stuff. I think the
Lights are not advancing.
Oh, yeah.
Sorry.
Hello? Hello, your slides are not advancing.
Thank you, sir. We'll see if we can fix that here. Any movement there, Ken?
No,
No. What am I going to do here? I'm still sharing. How's that?
well, try advancing or, yeah, that seems to be working.
Good. Thanks, Ken. Attic air sealing, top priority, as we say, the heat rises through the attic penetrations, and we generally have quite a few penetrations in our attic planes now. So that ceiling plane, typically our poly layer in the attic space, can easily be addressed with moving the insulation back, air sealing those penetrations through the drywall layer, through your vapor diffusion, and in this case, default air barrier as well. So sealing up those locations. You can see here visibly partition walls, our methane stacks, our plumbing penetrations, our hot lights, especially around chimney penetrations. With the brick chimney, there's blow by top plates from interior walls. Quite a number of locations that we can address with very simple procedures and products within the attic space. So at duct penetrations, we pull the insulation back and we can use either firestop type materials or typical high performance sealants to seal around duct penetrations. Exhaust fans can be addressed with, in this case, the example was just some type 4 insulation, some extruded polystyrene that cut into a box and taped and placed over your exhaust fan penetrations. It can be done with a plywood box. There is off-the-shelf poly pans that can be placed over these elements. Perimeter top plates, lots of air leakage typically at the perimeter top plates. At combustion exhaust areas, we can use sheet metal to maintain my distances from combustibles. And with the adding some firestop sealant to air to create an airtight penetration. Recessed hot lights. There's a bunch of off-the-shelf products, as well as like I say, you can make your own boxes and have them either pop or tape to your vapor barrier. Attic hatches are a massive funnel because they're never effectively sealed, or they're just weighted on a gasket and they're not actually clamped into place to create a compression seal. Like I say, masonry chimneys, always an excellent location to stop a lot of air leakage. Ceiling bulkheads, we have drop ceiling penetrations, using spray foams in those locations, and then top plates of interior walls, especially where plumbing penetrations come through, either gaskets, tapes, or sealants to seal up those penetrations. So an attic flash and fill, spray foam air sealing. So what we would do is pull back all the interior insulation, do a 2-inch lift of spray foam insulation that would give us an air barrier as well as our first layer of insulation, and then adding insulation to the top. So you don't need to spend big bucks on a lot of it spray foam. You only need that first 2 inches. So important considerations for attic work: the air barrier base material is either the back side of the interior finished drywall or the existing polyethylene within the attic. Spray foam does not stick well to polyethylene, so use tapes and sealants instead. And keep all combustible materials clear of hot combustion exhaust surfaces. Superficial air sealing from the interior surface of the ceiling is less effective, but can work if needed. And if more substantial retrofit work is planned, install a new continuous sealing air barrier, polyethylene, or consider converting the attic to conditioned space. Condensation and moisture-related problems can occur due to air leakage combined with the added or upgraded insulation. For all procedures, air sealing work must be always performed prior to insulating. So those these where we have wires coming up in the attic, they have the electrical supply has a putty material, fire stop putty, and we just make a worm of that putty, wrap it around the wire, and press it into that opening, and it creates a good durable seal that can last for minutes. It maintains its viscosity and lasts quite a long time. And then we can see the penetration for the venting. So we already have a pan to hold back the material from combustibles. And in this scene, we just need simply a fire stop cock from the middle of the supplier. Important considerations for attic work: sealing and insulating attic duct runs is vital to avoid potential moisture issues in the attic. A lot of our open, unconditioned attic space already suffer from night sky radiation impact. So we have warm, moist air in there. And as soon as that sun goes down, the night sky radiation sucks that warm air right off the attic surface. We have every single nail within the attic space, a little bit of moisture on every single nail. And so that's a function of wetting and drying. So we may not notice any leaks within the attic, but every night that attic has a little rain droplets up there, and we don't even know. And then this is a medium path where we don't have continuity or seal, and then we have leakage through that thermal sleeve. If I've got a penetration an elbow down further, it's leaking within that cavity, but it's all rising and impacting at the most condensed surface, which is the plywood, with no thermal layers there to diffuse it. So other targeted above grade air sealing, explode spores, as were mentioned before. So we have to pull the soffit material down, make sure there's an air seal application, and then insulate that cavity space. Direct wall penetrations from the inside can easily be gasketed. There's quite a number of products on the market now to make those penetrations easier. Knee walls in attics, another one that often gets bypassed as part of that enclosed assembly. Floor joist penetrations at the rim joisting or headers. And wall miscellaneous penetrations. There's Fortis provides gasket kits as a free upgrade. So you can get, I don't know if they still do it, but they used to do it. So you can get gasket kits for all your interior light switch plugs, your wall plugs. Under the sinks, it's one that often gets missed, is that plumbing penetration. That's usually a big hole. I actually felt a draft standing in a home the other day. I was in front of the sink. I was inspecting the window and I felt a draft at my ankles, and opened underneath the sink, and there's a bloody hole in there. You could feel it blasting in. And then vaulted ceiling, roof ceiling at any penetrations in that assembly, especially skylights, which skylights are always quite leaky and never really addressed effectively as far as a gasketed seal. Low-grade air sealing, and this is what we're saying about converting a low-grade space into a conditioned space. So I would address the elements within that space and turn them into a conditioned space. It's not, in this case, it's a vented low-grade area. And so it's not considered part of the conditioned space of the home, but it has a major impact on the stock effect of that home. So I want to air seal and isolate that area. So your sealed slab membrane for moisture and air, and that's a radon penetration coming up through the slab assembly. Floor over crawl space going around at the headers, major leak point at that detailing that we're sitting on the framing to concrete connection, which is not air sealed, as well as all the boxing. And so slab repairs and sealant, sealing up any cracks in the slab as a potential for air leakage, and wall miscellaneous sealing, especially cracks in your concrete parapet walls. There's considerable amount of air leakage can leak through those areas if you don't have the soil outside or any way of diffusing it. Important considerations for the low grade: deal with the moisture first. Concrete cracks, foundation drainage issues, etc. Keep crawl space ventilation and left converting it into conditioned space. So you can get thermal cycling within your frame walls on your concrete basements. So there's quite a bit of impact there. In the investigative process, there's the musty smell, but no visible mold or anything. But when we open up the walls, the concrete sweating in the winter months. And so it's again that function of wetting and drying between the seasons. You may not see it, but you experience that musty basement smell. Windows and doors. Seal existing windows and doors. Seal from the interior only to avoid trapping moisture. Do not seal operable portions. Apply sealant to joints and perimeter, and consider replacing gaskets, especially to work and adjusting hardware. And we say adjusting hardware, which we're saying to make sure that we're getting that compression of the gaskets within the window. Obviously, a slider window is not going to get that, but that's why we don't have slider windows anymore in the marketplace.
Why just the interior of the windows?
Because if I was to seal on the outside of this window, within these planes, I might be trapping moisture because I have a lower thermal gradient there. I don't have a lot of diffusion, so I'll end up with condensing.
So water penetration is not an issue.
No, the water penetration, the window should have its built-in venting, it's venting drain incidental moisture within the unit. Yep. But we don't want to seal on the outside because we're creating film on the outside, which creates potential condensation. We get in this time of year, we get a freeze thaw within that window assembly, and we blow the frame apart. Existing doors, sealing the existing doors and windows, and replace bulb gaskets around doors. Avoid the brushes or consumer grade foam weather stripping, and do not rely on sealant to water tightness. Add exterior flashing if needed. So in this case, it's not a good representation. We added a head flashing for the window, like regulated issue. 3/4 inch layer stucco. That's not an advisable process. Then alternative air sealing approaches, we kind of have to touch on this. What we're seeing there is a broadcast unit for a product called aero barrier. It's a coagulant that gets brought in. We depressurize the home, pressurize the home, add a coagulant into the air. That coagulant finds the penetration, the air leak penetrations, and seals them up. It's a great application. You're at drywall stage. You've just installed the drywall, ready for lockup. You've really done a blower, mid-door blower door test. You realize that you haven't quite hit the mark that you needed. This will solve that problem. But as the home ages, I make penetrations within the wall. I hang a picture on the wall. Anything that I do after that fact is going to affect the air barrier. It's a great way to get an instant, air tightness metric, but it's not going to solve your problems in the long run as far as durability. It's an aerosol sealant sprayed throughout the house, seals leakage path and passes through them. Suppliers claim to be capable of sealing gaps up to 1/2 inch. I've actually seen quite a bit bigger gaps. You can add a mesh matrix over large holes. We did a 3-inch hole and just added a drywall mesh to it and then coagulated and plugged that hole. It's a non-invasive application through, though it still needs to protect finishes, and it's reasonable the cost will come down, but it's relatively high cost, especially when you factor in your long-term performance values.
What is the product?
It's an aerosolized gel. It's it's just a liquid gel that as it hits that penetration, it sticks to that surface and continues to build up on itself until eventually plugging the hole. It's called Aero Barrier is the company out there. There's only one company doing it really in the market corner. Full air barrier retrofit, that's done during other upgrades. Exterior air barriers, I'm a huge proponent of. You get the best bang for your buck, as well as a much more durable envelope. You can go with rock salt type materials and create a non-combustible exterior envelope. If I was to use a hardy finish or a cementitious finish on the outside of that, very durable assembly. But also as interior barriers, we can utilize products like called smart barriers. Quite a number of products on the market. You can achieve that through just poly and tape and gaskets as your interior air barrier and vapor diffusion layer. Session review, air sealing is one of the most effective ways to improve the energy efficiency and comfort. Ventilation is important. Use appropriate tools and materials. Many sealing added details to air seal. Quite a bit of things up there. Other air sealing typically done from the interior. Keep in mind windows and doors are a common culprit, and other air sealing approaches include aerosolized sealant and full retrofit work. That's it. Questions?
Okay, check them on here. All right, so Jeff just finished up here. I'm going to check our online chat to see. So if you have any questions in person, feel free. If you have any questions online, you can punch into the chat, or I believe you should have the ability to just unmute yourself as well. Yeah, so there's some questions about the entire screen, not just the slides. Yeah, we haven't figured that out yet. Online, it's not showing the entire slide. It's showing the like the presentation mode where you have your notes and things, and we haven't quite figured out how to fix that yet.
Maybe the slide deck can be put on available.
Yeah, I will make tonight's slide deck available. Can I make your slides available? Yeah. And I will also follow up with some material, some support material around air sealing. There's some good products produced by the province and as well as by the Fed that guides you through different steps of air sealing. There were a couple of points I want to follow on as well. Home of the system. So we talked about this last talk. Jeff also touched on it tonight. But as we air seal, we start to see other issues that creep into the home, which brings in ventilation as a critical issue. And we aren't going to talk about ventilation specifically this year, but we have a recorded talk of it from last year. So if you check out our YouTube page, you'll be able to find that and walk you through some ventilation stuff. The other thing Jeff mentioned that we haven't talked about is radon. And radon is a natural occurring gas in our soils, and certain regions have higher levels than others. Roslyn is one of the regions of this. And if I'm not mistaken, it's the second leading cause of lung cancer, which is kind of a shocking fact. And as we air seal, that radon issue can become more of a problem if not properly ventilated. With any air leakage in your house through the soil can stay in house longer, you're not getting the same changes. So just another thing to think about. Trail Public Library has radon testers that you can borrow. You put them in your house for a week or a month, and they give you sort of a baseline average, and then you can check out those numbers and just see where it's at in terms of risk tolerance.
It's quite prominent here in the Kootenays, and I do advise that that you can do long-term test kits that'll go for a year.
Okay.
So you can purchase the kits and then you submit them to a testing agency,
Okay.
and you can do short-term test kits as well. I suggest anybody that's concerned, because there is quite a few areas within the Kootenays that are highly susceptible to radon. And I do suggest that even if you do a short-term kit, it's worthwhile to do a long-term kit just for peace of mind.
Yeah.
So short-term kits are before you, is with the library?
Yeah, that's what the library has. And I can't remember to keep it for a week or for a month. And the long-term kits I've seen, they're just like these little discs.
Very non-invasive.
Yeah.
In the corner, leave it, and you can take it and set a reminder for a year from now and then submit it.
Yeah, you mail it away. And
Yeah.
do the results.
Although I guess short-term would show, if it shows any.
It does to a degree, yeah. If you have a large concentration, you're gonna know obviously within the short-term kit. If you have mild, it may or may not show up necessarily on a short-term kit.
I think it's also a seasonal thing.
Yeah.
So in the summer, you've got your windows open, you've got better ventilation, you don't have to test as much. So you test in summer, it's fine. And then winter comes and you close it.
The websites advise testing during those off seasons.
Yeah.
Whenever it's.
Yeah.
All right, no questions coming through online. Yeah, just a reminder about those infrared cameras available at the library for loan. There's some instructional material that we put together with them to walk you through the kits. They're compatible, one's compatible with iPhones, one's compatible with Androids. And then we also have this is something that I'll mail out or email to everybody, but that we also have with the kits is basically a do-it-yourself home energy audit and air sealing tips that City of Vancouver put together. But it's quite a user-friendly homeowner sort of first step into getting into air sealing, if that's something, if you're ready to tackle on your own. So if there's nothing else from anybody, and I'm not missing anything, thanks a lot for coming out tonight, Jeff, and walking us through that. It's great to have you in the region now with your knowledge and sharing it.
No problem.
Jeff's doing some work with contractors as part of the Retrofit Assist program. So hopefully we'll have sort of more contractors in the region that are up to snuff on this modern building science. And
I've got my email address there, so if anybody has any questions or wants additional information, then I'm always available for reference.
all right, perfect. And our next talk is in 2 weeks from today. We'll be doing it in person in Miners Hall again, and then live online. And I'll send out a reminder about that. So hope to see everybody there.
No problem.
Yeah. Thanks to think about it.
It is, it's always interesting to me.